Good morning. Last time we did this qualitative analysis to find the color of different metallic ions. That means determination of metallic ions by reacting them with sodium hydroxide and ammonium hydroxide. Today we'll be doing something new, that is action of alkalis on certain metals. All metals do not react with alkalis. Alkalis means sodium hydroxide, potassium hydroxide. So all metals do not react. Few metals are there which reacts with alkalis to give compound. We know that when metal reacts with acid, we get salt plus hydrogen gas. When metal reacts with acid, we get salt plus hydrogen gas. Similarly, there are some metals which reacts with alkalis to give salt plus hydrogen gas. So, these metals are zinc, aluminium and lead. So, how many metals are there? Only 3 metals can react with alkali to give salt plus hydrogen gas. So, these metals are zinc, aluminium and lead. So, generally zinc reacts with hot and concentrated alkalis. But aluminium, it does not react with hot and concentrated alkalis only. It reacts with boiling caustic alkali solution. It can be sodium hydroxide solution or it can be potassium hydroxide solution. So, aluminium reacts with boiling caustic alkali solution, but zinc and lead can react with hot and concentrated sodium hydroxide solution to give salt plus hydrogen gas. So we'll see how it reacts now. So zinc plus sodium hydroxide. We have already done actually, but then also since it is in the syllabus, so I am repeating it. Otherwise, we have already done it in chapter 3, acid, bases and salts. We have already done. So zinc plus sodium hydroxide gives Na2ZnO2 plus hydrogen gas. Na2ZnO2 plus hydrogen gas. So what is this Na2ZnO2? What is the name for this compound? This is sodium zincate. And this is colorless. And soluble also. This is soluble in water soluble. We have already done this in the last class also. When excess of sodium hydroxide reacts with zinc hydroxide, will get sodium zincate as a soluble compound, and there will be no precipitate. So sodium zincate is soluble in water. Sodium zincate, and will get hydrogen gas. And the reaction is balanced. Okay. So since sodium and potassium lie in the same group in group number 1 in the periodic table, so they will have similar properties. So whatever kind of compound sodium makes, potassium also does the same. So here we will be getting K2ZnO2 plus hydrogen gas. This is hydrogen gas. So sodium zincate, and here it is potassium zincate. It is also colorless and soluble. So why this is colorless is because zinc is colorless and potassium hydroxide is also colorless. So we will be getting colorless salt. So acid, metal plus acid gives salt plus hydrogen gas. Metal plus base also gives salt plus hydrogen gas. But here base must be alkali. Base must be alkali and metal must be zinc, aluminium and lead. No other than this metal can react with alkalis. Okay. So this is the reaction between zinc and alkali, sodium hydroxide as well as potassium hydroxide. So we'll begin now with aluminium. See, aluminium Al, and this not only reacts with sodium hydroxide, but it needs solution of sodium hydroxide. It needs solution of sodium hydroxide. That means sodium hydroxide in water. Solution of sodium hydroxide. So what happens when aluminium reacts with sodium hydroxide solution? So we will be getting NaAlO2 plus hydrogen gas. Now NaAlO2, what is the name for this? Last night I have said you ZnO2 is zincate and it is acid radical. AlO2 is aluminate, meta-aluminate, and it is also acid radical. So we will be writing here sodium meta-aluminate, sodium meta-aluminate, sodium meta-aluminate. So 2, here also 2, Na2, Al2, then O4, O2 and 2, 4, hydrogen 2 2s are 4, 2 2s are 4. Okay, 2 2s are 4 and 2 6. So here is 3. Okay, so when aluminium reacts with boiling caustic alkali solution, we will be getting sodium meta-aluminate plus hydrogen gas. Similarly, when aluminium, here also same thing because they have the similar properties. Plus 2KOH plus 2H2O, same thing, boiling potassium hydroxide solution, boiling potassium hydroxide solution. When it reacts with boiling potassium hydroxide solution, we will be getting KaLO2. What is the name for this? Potassium meta-aluminate. Potassium meta-aluminate plus hydrogen gas. So in this way, when aluminium reacts with the solution of potassium hydroxide and sodium hydroxide, they will be getting salt plus hydrogen gas. And what is the name of the salt? Meta-aluminate. If it is sodium hydroxide, sodium meta-aluminate. If it is potassium hydroxide, then potassium meta-aluminate. Similarly here, another aluminium reacts with fused alkali. Fused alkali means when you keep this alkali in the cube in the porcelain dish, okay, then when you heat this, it will break. Fusion means to break. So then hot alkali directly, fused alkali, hot alkali, fused alkali, then it gives sodium aluminate. Then it do not give sodium meta-aluminate, then it directly gives sodium aluminate. It directly gives sodium aluminate. So what is sodium aluminate? Na3AlO3. This is sodium aluminate. This is sodium aluminate plus hydrogen gas. Sodium aluminate plus hydrogen gas. 6Na, so this is then 2Al, O6 and 6. Okay. So this way aluminium reacts with boiling caustic alkali solution and boiling potassium hydroxide solution as well alkalis. So when it reacts with boiling solution, it gives metaluminate. When it reacts with fused alkali, it gives aluminate. Not metaluminate, it gives aluminate. Okay. Then comes lead. Lead plus sodium hydroxide. Lead plus sodium hydroxide. Okay, one thing I missed here. Here also, this is colorless aluminium. Lies in group 13. So colorless ion, colorless. This is also colorless. This is also colorless. So what must be the color of this? This is also colorless. This is also colorless, and this is also potassium metaluminate is also colorless. This is also colorless. This is also colorless. Colorless. All of these salts are colorless. Now lead plus sodium hydroxide. Lead plus sodium hydroxide. So what kind of sodium hydroxide? Hot and concentrated. Hot and concentrated. So when lead reacts with hot and concentrated sodium hydroxide, it gives sodium chloride. It gives sodium chloride. What it gives? It gives sodium chloride. So what is the name of this salt? This is sodium chloride. So what is the color of this sodium chloride? It is also colorless. Colorless. Plus hydrogen gas. It gives sodium chloride plus hydrogen gas. Sodium chloride plus hydrogen gas. Na2, so make this 2. Then Pb1, then oxygen 2, hydrogen 2, hydrogen 2. Okay. Now when lead reacts with potassium hydroxide, it also should be hot and concentrated. Then it gives potassium chloride. It gives potassium chloride. Potassium chloride plus hydrogen gas. Okay. So this is all about when metal reacts with alkalis. This is all about when metal reacts with alkalis. Okay. So when zinc, that means you got it. When zinc reacts with alkali, it gives zincate. When aluminium reacts with alkali, it gives aluminate. When lead reacts with alkali, it gives chloride. Now, similarly, there are some metallic oxides and hydroxides. There are some metallic oxides and hydroxides. Metallic oxides and hydroxides which exhibit dual character. This also I discussed with you when I was teaching base. So some of the metal oxides or metal hydroxides exhibits dual character. That is, they show acidic as well as basic character. Acidic as well as basic character. That means when these oxides, metal oxides or metal hydroxides reacts with acid, they behave as base and give salt plus water. But when they react with alkali, when these metal oxide or metal hydroxide reacts with alkali, then they give salt plus water. Here they behave as acid. When they react with alkali, they behave as acid. When they react with acid, they behave as base. So they show both the character, and that's why these metal oxides or metal hydroxides are said to be amphoteric in nature. They are said to be amphoteric in nature. Amphoteric means showing both acidic as well as basic character. We'll see action of alkalis on certain metallic oxides or hydroxides. And these metallic oxides or hydroxides has to be amphoteric. Amphoteric means having both, showing both acidic as well as basic character. Acidic as well as basic character in nature. So when this zinc oxide, that means zinc oxide, aluminium oxide, lead oxide and their hydroxides are amphoteric in nature. They can show both acidic as well as basic character. That means when they react with alkali, they behave as acid and give salt plus water. As we know that base plus acid gives salt plus water. Base plus acid gives salt plus water. So when these amphoteric oxides or hydroxides react with acid, they behave as base and give salt and water. But when they react with alkali, they behave as acid and give salt and water. And give salt and water. Okay. So zinc oxide, zinc hydroxide, zinc oxide and zinc hydroxide reacts with sodium hydroxide to give salt and water. Now zinc oxide, what is the color of zinc oxide? White. When reacts with sodium hydroxide, gives sodium zincate. Gives sodium zincate plus water. Gives sodium zincate plus water. Same thing. When zinc reacts with this, product is same, but we will be getting hydrogen gas. But here when oxide is there, then we will be getting water. When only metal reacts, we will get hydrogen gas. Product will be salt, will be same. But when oxide is there, then we will get water and no hydrogen gas. Now zinc hydroxide, when reacts with sodium hydroxide, the salt is same. The salt is same. Sodium zincate. The salt is same. That is, what is the name of the salt? Sodium zincate. Sodium zincate. We will get the same salt, sodium zincate, plus 2 molecules of water. Now I am telling you the difference. When zinc reacts with sodium hydroxide, we will get sodium zincate plus hydrogen gas. When we react with zinc oxide, we will be getting 1 molecule of water. When we react with hydroxide, then we will be getting 2 molecules of water. That is the difference. Now in your syllabus, what is there is you have to do with potassium hydroxide also. So whenever you will be doing with potassium hydroxide, it is very simple. See, in place of sodium you have to write potassium. That in place of sodium you have to write potassium and nothing will change. Nothing will change. K2ZnO2. K2ZnO2. But this will now be potassium zincate. That's it. So no change at all. No change. Same product you will get, only in place of sodium you have to write potassium. That's it. Now aluminium oxide or aluminium hydroxide, when reacts with sodium hydroxide, it gives sodium meta-aluminate. Same thing. Aluminium, when reacts with boiling caustic alkali, we were getting the same product, sodium meta-aluminate and hydrogen gas. But here, since it is oxide, so water. Since it is hydroxide, 2 molecules of water. Same throughout. So this is white in color. Aluminium oxide is white in color, and this is also colorless. So this is also, the salt is also colorless. Now here, aluminium hydroxide reacts with sodium hydroxide to give sodium meta-aluminate, which is colorless, plus 2 molecules of water. Similarly here also, if you have to react with potassium hydroxide, then simply what you do is you put K in place of Na. K in place of Na. Then here also you do the same thing. K in place of Na. And here it will be potassium meta-aluminate. Potassium meta-aluminate. Okay. Then with lead oxide also same thing. Lead plus sodium hydroxide goes giving sodium plumbite plus hydrogen gas. If it is oxide, then water molecule. If it is hydroxide, then 2 molecules of water. Same thing. It will be easy for you to learn. Okay. So what you need to learn is metal plus alkali gives hydrogen gas. Metal oxide, amphoteric oxide plus alkali gives 1 molecule of water. Then amphoteric hydroxide plus alkali gives 2 molecules of water. That much only. The product will remain the same. Product will remain same. So here lead oxide is yellow in color, but salt form will be colorless. Salt form will be colorless, and this is soluble in water. Last time we did. Yes, excess of sodium hydroxide. If we add excess of sodium hydroxide in lead hydroxide, then we will be getting soluble compound of sodium, that is sodium lumbite. Sodium lumbite. This is soluble in water. So there will be no precipitate left, but this is precipitate. And what is the color of this precipitate? Chalky white. It was chalky white. It was chalky white. It was chalky white. This insoluble substance, chalky white. But this is soluble substance and it is colorless. It is colorless because this is compound of sodium. So colorless. Plus 2 molecules of water. Here also, if you want to react it with potassium, then same thing you have to do here also. Here you need to write K. K. Simply you have to change. You have to change N. And in place of N you have to write K. In place of N you have to write K. Okay. So this actually we have already done in 3rd chapter, but then also since it is in the syllabus and it will be good to repeat so that it will be clear to you, I will do it. Now, hope this is understood, and with this only we have finished chapter number 4, Analytical Chemistry. If there is any problem you can ask me through WhatsApp. And I hope you will see this video and try to solve the question answers followed by it. And the previous year questions for this chapter is there in last chapter, that is practicals. In that, the question related to this that had come in the previous year is there. So you can go to last chapter and check the questions that has come. Okay, this much for today. Thank you.